Okay, now we're going into the second part of chapter two. The next component of physical fitness, I'm sorry if you can see it here, would be muscular endurance. And muscular endurance is actually defined, and I did this specifically. I did this on purpose because I want you to go ahead and know the difference between muscular endurance and cardiorespiratory endurance. Muscular endurance has to do with the ability of skeletal muscle to sustain a certain amount of energy within a required time period. So, muscular endurance can be anywhere between 30 seconds to 2 minutes, something. And one example would be, oh, I'm sorry, when I put down a 1 rep max bench press, that actually isn't the right tool. For muscular endurance, you can do sit ups, pull ups, or even planks. Again, please make sure that you know that the 1 rep max bench press has more to do with muscular strength. Okay, muscular strength, by the way, has to do with the ability to pull, push, carry, or lift an object within, uh, within a single effort. Again, that has to do with the ability to push, pull, carry, or lift an object within a single effort. Now, now that you know muscular endurance and muscular strength, even though you couldn't see the definition of that, now we're going to go into cardiorespiratory endurance. This is the different type of endurance, as I mentioned earlier. This has to do with the ability of the cardiorespiratory system, and I included the items of that system, the heart, lungs, and blood vessels, just to name a few, to produce aerobic capacity. It is the same thing as oxygen consumption, which we're going to talk about in a little bit, within a certain period of time. Again, that has to do with the ability of the cardiorespiratory system to produce aerobic capacity within a certain period of time. And these are just a few of the ways to test for cardiorespiratory endurance. One of them is the 1.5 mile walk jog test. Okay, and you definitely need a stopwatch. You definitely need to know how long the distance is before you attempt this test. And we have what's called the 3 minute step test. Now, in comparison to the walk and jog test, the step test is relatively easy to do. You just need to have a stepper, which is a long board that people use to step on, the risers, a stopwatch, and someone who actually is really good with keeping time. Okay, now here are the things we covered this last Saturday. However, I feel like we really kind of rushed through. So there are actually three energy systems you need to know that are responsible for producing ATP. ATP, by the way, is an energy molecule, and we'll a little bit. The first one is called the phosphagen system. The phosphagen system basically is characterized um, by short, intense spurts of energy. And when we're talking about phosphagens, we're basically talking about phosphates. And there are two of them you need to know. One is called CP. CP actually stands for, as you can see, creatine phosphate. It's also known as phosphocreatine. Okay, so that's one of the phosphates you need to know. ATP, as I mentioned before, is your energy molecule, and ATP actually is based on creatine phosphate. So if you use the creatine phosphate, if you metabolize that, ATP is going to be produced. However, creatine phosphate is only used within 10 seconds or less, so it has to be hard, heavy, and very fast activity for you to utilize CP. Okay, now as I mentioned before, is characterized by intense short spurts of energy, and I put down speed as an example, less than 10 seconds. However, when it's actually, in comparison to the other two, this is the one that you can do sprinting, running, something that's very intense, or even if you're about to fall and you recover quickly, that's definitely using CP as well. Okay, now the second one, however, now this is called anaerobic glycolysis. Anaerobic glycolysis. Now let's look at the term glycolysis for a moment. Glycolysis, when you look at that term, LYS actually means to break down. Glyco means to break down. Glyco means glucose, just in layman's terms, sugar. Okay. Now, when we go to the anaerobic part, when we think about aerobic, no, don't think about being in step class or spinning or something like that. However, those activities do use oxygen, so they do have something to do with this term. Now, I'm going to go ahead and try to cover with my big finger here. Okay, I guess it's not working. Okay, I'll just block it off here. When you look at aerobic, aerobic means basically air or oxygen. When we put down the AN part, AN means without the presence. So literally, it means without the presence of oxygen. So together, making this a working definition, anaerobic glycolysis has to do with the breakdown of sugar without the presence of oxygen. Wow. What can we do to break down that sugar if we have no oxygen? Well, we have what are called glycolytic enzymes. Enzymes are catalysts of metabolism. So for us to break down a Snickers bar, a granola, we need those enzymes. And those enzymes, as I mentioned from one video, are found in the stomach. It's definitely in the digestive system. So let's go down here for a moment. As I just said, breaking down glucose or glycogen, which is stored glucose without oxygen, and instead of oxygen, you take glycolytic enzymes. Okay. However, now when those enzymes do their jobs and they break down the carbohydrates, then the waste products produced are pyruvate or pyruvic acid. So when you see pyruvate, it's the same thing as pyruvic acid. And later on, as you keep breaking down that sucker, then you have what's called lactate, which is also known as lactic acid. Okay. So by the way, when you look at ATE usually pertains to a salt, okay? So always know it has to do, ATE is a salt. ASE, as you saw from the one earlier video or covered in class Saturday, means enzyme, but not all the time, okay? So please be aware of that. Okay, so that's what's happening. So when you feel that burning sensation in your muscle, guess what? That's that lactic acid buildup. That's all it is, okay? So how do we get rid of that lactic acid buildup? Well, I'm glad you asked. I'll tell you what, we're not going to cover that just yet, but we're going to talk about what's called EPOC, which essentially means excess post-exercise oxygen consumption, and we can tell how you get rid of the lactic acid burnout. Okay, the last energy system we're going to cover would be what's called aerobic glycolysis. Now, as you already remember, glycolysis has more to do with the breakdown of sugar. Aerobic has to do now with the presence, since we don't have the prefix an next to aerobic. Hey, we basically know, hey, you can break down sugar with the use of oxygen. Okay, so this basically means breaking down glucose molecule in the presence of oxygen. No brainer, right? Okay, so now, however, even though we're breaking down glucose, guess what? When you're talking about air now, when you're talking about air, you can also break down fat molecules. So it involves the oxidation of fat molecules. Okay, and here is what I was talking about, epoch. Okay, now I'm going to try as hard as I can to make sure that you can see this. Now, the far left from the long arrows moving north and south up into oxygen deficit, you aren't doing a thing at all. In fact, you're only preparing. However, when you see the oxygen deficit and as you see that curve, you are about to utilize oxygen from the environment. Okay, you're about to go ahead and use it. You're going to start off as slow pace. Well, I'm not going to lie to you about that. You're not going to start off at a slow pace just then and there. You're actually going to use the CP ATP system. I'm sorry, ATP-CP system, the phosphagen. That means within the first 10 seconds or less, you're going to go ahead and sprint. So now, as you are about to climb up, let me go ahead and as you can go ahead and move upward, now you're going to start picking up the pace. Okay, this is where your anaerobic glycolysis, your lactic acid system is about to go ahead and kick into overdrive, because now from this point, from the ATP-CP system, where it's a quick spurts of energy, now you're going to go a little harder and heavier. In other words, the heart has to go ahead and start pumping oxygen um, by way of the bloodstream to the rest of the body. That's what's happening here. So the heart is going hard and heavy to meet the demands of the body for oxygen. Okay, now, once we get from the oxygen deficit up into this point here is called homeostasis. Homeostasis is a steady state. This is where the body is actually adapting to the changes now. The body is becoming familiar with the terrain, it's becoming familiar with the heat and so forth. Okay, so the body, relatively speaking, the body is in a good state if the person is healthy enough. Okay, now this is where it's really important for you to understand the concepts of what's happening to your body during exercise. Now, from oxygen deficit to steady state or homeostasis. Here, this is where the body is undergoing some changes here. It's responding to heat, it's responding to the environment, it's responding to the terrain uh, on which the person is running, all these things. Now, this is where the heart is extracting blood to the rest of the body for oxygen. Stroke volume, as you can see with the initials, stroke volume is the amount of blood that the heart is extracting. Now, with heart rate and stroke volume together, they make up what's called cardiac output. Now, cardiac output is really important. The concept is this: if the stroke volume, if the amount of blood isn't enough to compensate for that, the heart would have to beat a little harder to send the blood out to the rest of the body. In 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 contrast, if the heart rate is very shallow, then the amount of blood has to be sent to the rest. You have to have a higher amount of blood to be sent to the rest of the body for oxygen. Okay, so it's like you have to compensate if one aspect of the heart isn't strong enough, of cardiac output isn't strong enough, then the other one has to compensate for the other one. Okay, blood pressure has to be hard. So blood pressure along with cardiac output, it's really about supply and demand. It's really about supply and demand. Okay. Now, commencement of exercise from right here, going right back here. Okay, so from here up to here, this is where those changes are happening. Okay, now once we get to here, that's when I told you about the lactic acid buildup. The lactic acid buildup is now beginning to decrease. Okay, this is because why? This is because the person is now cooling down. They're actually making up for that lactic acid burn. And what do you do at this point? The heart rate goes down, lactic acid buildup goes down. We have what's called anaerobic threshold. Basically, you're tolerating the amount of lactic acid buildup that's actually happening in your muscles. Now, as you breathe, then you're actually reducing the amount of lactic acid. Okay. All right. That's EPOD. That's exercise, post-exercise oxygen consumption. All right. That's chapter 2 in a nutshell. If you have any questions, please feel free to ask in class. And by the way, one thing I want you to know, with the lectures, it shouldn't be all about me giving you the answers. I want you to go ahead and research them for yourselves, bring the ideas to class, and let's really challenge each other to think beyond what's given in the textbook and think outside the box. This is David, and you have a terrific day.